Our universe is constantly expanding, a phenomenon that makes it incredibly difficult to establish its true limits or measure its actual size. Yet, through advancements in space exploration, especially with the help of the James Webb Space Telescope, we are now able to peer deeper into the cosmos than ever before. This powerful telescope allows us to glimpse into the most distant regions of the observable universe. Since the James Webb Space Telescope began its mission, many scientists, including notable astrophysicists like Professor Brian Cox, have made groundbreaking announcements revealing the immense scale of the universe. The vastness it presents is not only humbling, it's almost beyond comprehension. According to recent studies, within the observable universe, there are an estimated 2 trillion galaxies. These figures are derived from deep sky surveys and studies of our local cosmic neighborhood. However, we are quite confident that what we observe is merely a tiny fragment of what could be an infinite universe, one that continues to stretch far beyond the limits of our current detection. We are not separate from this universe. In fact, we are an integral part of it. As Carl Sagan eloquently put it, we are a way for the universe to know itself. With tools like the James Webb Space Telescope, we dive deeper into this cosmic ocean, seeking to better understand our origins and the true scale of all that exists. If you're interested in keeping up to date with discoveries about the universe, space exploration, and astronomy, don't forget to subscribe to our channel. Like this video, and turn on the notification bell to stay informed. Now, let's put the scale of the cosmos into perspective. If we traveled at a constant speed of 70 miles per hour, it would take about 15 days to complete just one lap around Earth's equator. To reach the Moon, it would take roughly 5 months. A trip to Mars at its closest point to Earth would take around 63 years, and to reach the distant planet Neptune, it would require an astounding 4,400 years at that same speed. Now consider the Voyager 1 spacecraft. Launched in 1977, it travels at a velocity of 38,000 miles per hour. Even at that remarkable speed, Voyager 1 took 35 years to leave the boundaries of our solar system, finally doing so in 2012. This illustrates just how vast our solar system truly is. Even light, which can circle the Earth 7 times in a single second, seems sluggish in the face of these vast cosmic distances. Yet, our solar system is a mere speck compared to the Milky Way galaxy. The Milky Way contains an estimated 300 billion stars, many of which likely host their own planetary systems. Our nearest stellar neighbor, Alpha Centauri, is 4.3 light-years away. This means that even if we could travel at the speed of light, it would take us over 4 years just to reach it. If a spacecraft were to travel to Alpha Centauri at the same speed as Voyager 1, it would take a mind-blowing 77,000 years to get there. This gives us a sobering idea of the true distances involved in interstellar travel. Let's consider another celestial object. Betelgeuse, a red supergiant star located about 640 light-years away. The light we see from Betelgeuse tonight actually began its journey toward Earth in the 14th century, long before the Renaissance, even before Columbus set sail for the New World. This ancient starlight is only now reaching us, a vivid reminder of the vast scales of time and space that define our universe. Now, consider the radiosphere, the bubble of space that contains all radio transmissions ever emitted by humanity. These signals, while incredibly weak now, have traveled outward at the speed of light for just over 100 years, reaching only about 15,000 nearby star systems. That's a mere fraction of the 300 billion stars in our galaxy. To put this into context, imagine shrinking our entire solar system down to the size of a quarter coin. In that case, the Milky Way would be roughly the size of North America. And within this enormous region, we're just one solar system out of hundreds of billions. But the universe doesn't stop at the edge of our galaxy. Far beyond the Milky Way lies an unimaginable number of other galaxies, at least 1 trillion more in the observable universe alone. To understand how vast a trillion is, consider this. Imagine a group of 1,000 cats. Now imagine 1,000 groups of 1,000 cats each. That gives you 1 million cats. Now take 1 million of those million cat groups, and you have 1 trillion. That's the kind of scale we're talking about when we consider galaxies in the universe. Our nearest galactic neighbor is the Andromeda Galaxy, located about 2.5 million light-years away. It's on a slow but inevitable collision course with the Milky Way. In about 4.5 billion years, these two galaxies will merge. Despite this collision, the vast distance between stars means it's highly unlikely that any will actually crash into one another. This again underscores the vast emptiness between objects in space. Zooming out further, we find that the Milky Way belongs to a local group of galaxies, which is part of the Virgo cluster, a collection of over 1,500 galaxies. The Virgo cluster is itself a small component of the Laniakea supercluster, a massive structure containing more than 100,000 galaxies. And still, this is just one of millions of superclusters that fill the observable universe. Despite our ever-expanding maps, we've only charted a tiny fraction of what's really out there. There are likely hundreds of billions of galaxies that remain unmapped, hidden in the darkness beyond our current reach. We must also consider the cosmic microwave background, CMB, the faint afterglow of the Big Bang. This radiation, which has been traveling for over 13.8 billion years, represents the oldest light in the universe. It is a window into the early cosmos, allowing us to glimpse the infant universe just 380,000 years after its birth. Beyond galaxies lie cosmic voids, immense, nearly empty regions that stretch across hundreds of millions of light-years. Though they may seem like vast nothingness, these voids are an integral part of the cosmic structure, potentially giving rise to new galaxies in the distant future. Then there are cosmic filaments, colossal strands of dark matter, gas, and galaxies that weave the cosmic web. These filaments, stretching across billions of light-years, link galaxy clusters together, shaping the universe at its largest scales. They form a sort of scaffolding that binds the cosmos through gravity, creating a stunningly complex, interconnected structure. Within these filaments, we find phenomena like supernovae, the explosive deaths of massive stars that spread heavy elements throughout the cosmos. Black holes, with their powerful gravitational pull, play a central role in galaxy formation and can launch jets of matter and energy across hundreds of thousands of light-years. Then there are quasars, the luminous cores of galaxies powered by supermassive black holes. These brilliant beacons can outshine entire galaxies and provide insight into the early universe. But what lies beyond the observable universe? Due to the continuous expansion of space, there are regions whose light hasn't reached us, and likely never will. These galaxies, while real, remain forever hidden from our view. Some physicists estimate that the entire universe could be at least 250 times larger than the observable portion, and possibly even infinite. If this is true, then our entire cosmic neighborhood is but a tiny island in an endless cosmic ocean. This perspective invites us to consider profound questions. Who are we in the grand scheme of the cosmos? What is our role as intelligent beings on a fragile planet orbiting a modest star, tucked away in an ordinary galaxy? In contemplating the universe's vastness, we not only marvel at the scale of it all, we also reflect on our own existence. Have you ever truly wondered just how immense the universe is? If so, we hope this journey has helped you grasp even a small part of its incomprehensible vastness. Use the comments below to share your thoughts or ask questions. If you enjoyed the video, hit the like button, share it with others, and subscribe to our channel for more captivating explorations of space, time, and everything in between. Thank you for watching, and we'll see you in the next one.